Yeah, guys. So we were doing production last time, and we looked at production function. We said production function is simply uh, a function that shows you a relationship between input and output. So we said this, that like the relationship between input and output is expressed in terms of a production process. And when we looked at that function, just 1 minute, guys. I think production process. So we said this, that the production process simply tells us the maximum output that we can make with different inputs. And we then talked about like short run versus long run. We said that short run is where at least one factor of production is fixed, while long run is defined as a time when all factors of production are variable except for technology. And the very long run, we said, is something where um, even technology is variable, right? And then we were looking at what we call a short-run production function. So I gave an example of a car wash company. We gave an example of a car wash company, and we made this table. We said this, that capital is fixed because we are in the short run. So capital is fixed. Labor is the variable factor, and I keep on adding labor on the fixed factors. When we keep on adding labor on the fixed factor, I will see my output to go up. So the first worker, for example, brought 30, the output went to 30. When there were two workers involved, the output went to 90, and then 130, 155, 172, and so on and so forth, right? So as you kept on adding labor, the output was increasing. But the more important part, the output was increasing. If you look at this, output was increasing at a different rate. And we said this, the rate at which output is increasing. So rate at which TP, this total product, was changing, at which TP is changing, is MP. Isn't that true? So MP is what? MP is change in TP over change in quantity of labor. Does that make sense? So it's the extra output that you're getting for extra labor. We came up with this MP values. We said this, that when you hire the first worker, your number of cars cleaned with 30. With two workers introduction, the number went to 90, which means 60 extra, and then 40 extra, and then 25. So for the first two worker, we found out that the output is increasing at an increasing rate. And the reason why I said this output was increasing at an increasing rate is because we saw MP is rising. Why does it happen? Is a discussion that we want to have right now. Why is MP rising? Is something which we're going to discuss right now. And then onwards, as you can see, onwards, your output is rising. Output is rising at a slower rate. And why is that so? Because MP is falling. So we want to today look at why is MP rising initially, why is MP falling? And I want to recap something else that we did last time, which is an important thing to look at. And if you have any questions, you can ask, basically. We also drew the diagrams for TP and MP. And today I'm going to add one more point to that diagram, which is going to be an interesting sort of addition. So this is my quantity of labor. Okay, so on my x-axis, I'm putting quantity of labor for each additional worker. We want to see how output is changing. So TP is your output, total product is your total output, and MP is your additional output as each worker is added. So we said this, that we can divide our diagram into kind of like two zones. Okay, initially output is going to rise at a faster rate. Remember, TP is rising but at a faster rate, and then TP starts to rise at a slower rate. Okay, something like this. But then there could be a possibility, and I'm going to draw this possibility with this blue line. TP can also fall, something which I'm going to explain in 1 minute. And similarly, there could be a possibility, because TP is rising, in the first part, TP is rising at a faster rate. The rate we said is slope. Remember that the slope of this line is change in TP over change in quantity of labor. So slope basically is your MP, and MP basically is going up, is rising. So when TP is rising at a faster rate, MP is rising, and then TP is rising at a slower rate, MP is falling. And then comes a point when TP is actually falling. We'll talk about this. MP will be negative. So I'm going to draw this, and I'm going to draw part of this as blue because I want to explain this blue part. Why does it happen that when MP is negative, TP is actually falling? So we want to talk about this. Before I talk about this, is there any question that we have? Haris, what is TP? TP is simply total output. Total output is called TP. Total product means total output. MP is the extra output from one additional unit of labor. Okay, MP is the extra output from one additional. So for example, the extra output from one additional worker was 30. The extra output from the second additional worker was 60. That's why total went to 90. So 0 plus 30 is 30. 30 plus 60 is 90. Then the next guy got 40 extra. Does that make sense? So that's why I won 30. So MP is the extra output. TP is the total output. Cumulatively, this is the output, and this is your MP, which is the extra output. Does that make sense? Are we good? But look at this, guys. What if the seventh worker, okay, actually ended up making the total go to, for example, 175? What if the seventh worker actually ended up causing the output to be falling? What if he comes in and rather than producing extra, something happens where he actually made a negative contribution? So that will make, in other words, when MP is negative, TP is falling. Why MP is negative? Why can MP be negative? Aapne bola ek banda la, you're bringing a guy and you're saying that MP is negative means something has happened. So we'll talk about that in 1 minute. But when MP is negative, when MP goes negative, we could see TP to fall. Okay, so that's what we want to see. So now let's talk about, let's call this zone 1, let's call this zone 2, and let's call this zone 3, and let's look into why are these things happening? Why is TP first rising at a faster rate? Why is TP rising at a slower rate later? And why is TP falling? Okay, so these 3 things are something which we want to look into. Okay, do we have any questions before we move on? Any questions, guys? Okay, so let's move on. So the first zone is we saying that MP is rising, or TP rising at a faster rate. Okay, the second one is MP is falling. We call it TP still rising at a slower rate, because every person that you hire is still contributing positively to the output, but his contribution is lower than what was brought by the worker before him. And the third one is MP is negative, where I'm saying TP falls. Okay, so why is this happening? Well, the reason why this is happening is basically to do with the first one is to do with uh, number one, or rather A, to make a difference. The reason why MP is rising initially, we say, can be because of two reasons. Number one is better utilization of capital. What do we mean by this? Guys, for example, if you have a machinery where you had only one worker working, he wasn't doing a good utilization, because let's say if I'm the guy who's the only one managing the whole washing plant, then first I will receive the money and the keys, I will drive the car, I will uh, make the car sort of wet, put some soap, dry the car, like do all the various steps on my own. And there will be time when basically, if there was more than one person, things could have been done better, because we could utilize capital. So initially we saw when the first guy was doing it all on his own, he was only able to do 30 cars. But when you had more than one person, the number of cars went up. It could be because of us utilizing capital better, or it could also be because of specialization, division of roles. He could take the money, I could drive the car, he could put the water, I could put the soap, he could do the interiors, I could do the exteriors, and so on and so forth, which means by dividing our roles, we can actually utilize capital better. Also, we can do specialization, both of which will make my output to rise at a faster rate initially. But then comes the third worker, and where we saw MP2 fall. And this happens because of something which we call law of diminishing marginal return returns, or another name for this is called law of variable proportion. What do we mean by law of diminishing marginal return or law of variable proportion? Well, we say that this is where basically the capital to labor ratio falls. So think of this way. Let's say right now I'm working on a table which is, let's say, 3 feet by 2 feet. Okay. And let's say Saud says to me, okay, sir, can I also work? And I say, yes, please go work. It's pretty ample for me. And next, it's basically Haris says to me, okay, sir, maybe I don't, maybe come should I, can I also come and sit and work? And I allow you to do that as well. So we keep on adding people to the table. The table size isn't changing. Table is a fixed factor. So in our example, capital was the fixed factor, but labor was the variable factor. So you keep on adding a variable factor to your fixed factor. Each and every variable factor will get less and less of capital to work with. Does that make sense? As you keep on adding more and more people to the same capital, every labor will get less and less capital. And therefore, the productivity of each additional worker will be lower than the one in the past, because the capital to labor ratio starts to fall. So each additional worker will get less and less of capital. And that basically causes what we call law of diminishing return. So you can call it labor to capital, but capital to labor means that, let's say, one capital over one worker ratio is 1:1. One capital over two worker ratio is half. Now the capital is divided into two people, versus 1:4 workers, capital is divided into four people. So 0.25 is what you get per worker, versus capital is divided into, like 8 workers. Does that make sense? So that's why it's called capital to labor ratio. Same capital, more labor, labor gets divided into more people, and therefore each worker will get less and less capital to work with, will get less and less capital, and therefore productivity, therefore MP is going down. Is it an economic law? And the answer is no, it's a physical law. Same physical capital, same capital, more labor. You can't expect the productivity to still go up because the labor isn't getting that much of capital. Does that make sense? Do we get the idea of law of, why is it called law of variable proportion? It's because the proportion in which you add the variable factor is basically causing the equation to change and therefore productivity to change. Okay, so the law of variable proportion is another name for law of diminishing return. So why does MP rise? Well, because you're utilizing your capital better and you're doing division of labor. Why does MP fall? Because same capital, more and more labor. Now, can we have the problem of law of diminishing return to happen in the long run? Is a question that I would want to ask you guys. Can we see the law of diminishing return to happen in the long run? So guys, in the long run, it won't happen. Why? Because in the long run, all factors are variable. So you can always increase more capital, which is a constraint in the short run. The reason why it's a physical constraint in the short run is because in the short run, our assumption is our fixed factors are not going to change. And now those fixed factors then cause what we call MP to fall. You may keep on adding the variable factor to get the output to go up, but then you will see that there will come a point when you'll be like, you know what, I need to stop because I am keeping on adding workers, but the workers are not really giving me incremental output. Make sense? So what we say is that in the long run, law of diminishing return may not happen, but it may happen only in the short run. And right now, yes, we are only talking about short run because this is the short run production. But the reason why I wanted to know is because there is a possibility that we may not see law of diminishing return happen in the long run because we can change the amount of capital to correspond with the amount of labor. So we say in the long run we have more possibilities that may not be available in the short run, and that's why, by the way, when you look at firms, when we evaluate firms' performance, we actually look at long run more than short run because in the long run they don't have much of constraints, and in the short run they do have constraints. So performance-wise, also when you look at a firm, you look at short run more like long run in order to see whether you are efficient or not. Something we'll discuss later. Okay, so the last point that I want to discuss here is about MP being negative. What happens when MP is negative? When MP is negative, guys, we say that this happens basically like in my table example. If you keep on adding workers, there comes a point, what if the seventh guy comes and he topples the table because let's say there's not much space? Or what if we end up having a negative productivity? TP is cumulative, yes, Harris, TP is cumulative and MP is additional. Amazing, that's the best way to put it. MP is the extra output of the additional worker, while TP is the cumulative output. Yes, that's the right way to look at it. So guys, MP is negative basically means it can happen primarily because the worker has probably come to a point where the contribution is actually negative, which means probably the system might break down. Probably this is the time when you should stop because you are now causing a harm to your overall total output. Okay. Now there is another thing that we want to talk about, which is AP. Look at what AP is. AP is an easy concept, and I want to sort of quickly move on to that one. What is AP? AP is simply average product. So if you look at AP is simply what we call average product. Average product basically means your total product is simply your total product over quantity of labor, right? In other words, this could be also called, average product can also be called simply output per worker. Okay, it could be output per worker. Do you guys get that? So what do we mean by this? So for example, look at this. when you had one worker, it was 30 divided by 1, so 30 is the answer. When you had two workers, 90 divided by 2, your AP is 90, is 45. 130 divided by 3, AP is 43. 155 divided by 4, AP is 39, 34, and 31. If you can look at the trend of AP also is rising and then AP starts to fall. Do you guys see that? So AP is simply average per worker. Are we good? Do you get the calculation of AP? If you want to write the values, you can right now, and I'm going to show you this in terms of a diagram. So guys, about AP, if I draw the diagram, let's just put AP here in this diagram. AP is just like this. AP rises, and as soon as it meets MP, okay, AP starts to fall. And let's call this point X. So AP rises and then AP falls. And I can say this, that I want to sort of write this line. It's an important thing to remember, that AP, when MP is above AP, AP rises. When MP is below AP, AP falls. Okay, and the third thing should be to notice is that MP meets AP at AP's maximum point. So three things we want to talk about. When the blue line, when the green line is above the white line is going up. When the green line is below the white line is going down. So when MP is above AP, AP rises. When MP is below AP, AP falls. And then when AP is maximum, that's when it meets MP. So why is this happening? I want to give you an example through, let's say, test. Okay, are we good to discuss this? So let's say you have three tests that takes place. Test number 1, 2, and 3. And this is your score on each test. I'm going to call it marginal score, because marginal means extra for each test, marginal score. And then I will find out your average score. Okay, in fact, we should do this marginal score. We should then have total score. And then we should find our average score. I should basically move these slightly. Let me move them so that it doesn't really destroy our diagram. Okay, so marginal score, and then total score. Okay, and then your average score. So marginal score for the first test, for example, जो आपने पहला test दिया, for the first test, let's say you score 20 out of 25. What is your total? 20. What is your average, guys? Can somebody tell me the average? The average will be also 20. Do you all agree? Does that make sense? What about second test? What if you score 24 out of 25? That's a good performance, 24 out of 25. What will happen to your total score? The total will go to 44. Isn't that true? And the average will go where? What will be the average? Average is 22. Now, guys, look at this. Why did the average go up? And the answer is you did better than the average. Your average was 20. You scored 24. You did better than the average went up. Isn't that true? Do you all agree with me? When you do better than the average goes up? Yes or no? If yes is the case, then I'm going to move on. Yeah. What about third test? What if in the third test you scored, let's say, what if in the third test you scored, let's say, uh, 16? Okay. What will be your total now? Your total will be 60. Isn't that true? If I'm not mistaken, is that total 60? Exactly. What is your average day for? 60 divided by 3, 20. What made your average go down again? You do worse than the average, your average was 22. You do worse than the average went down. Do you guys get the idea? So when MP is above AP, guys, when MP is above AP, you're doing better than the average. If you do better than the average, you pull up average. AP rises. When MP is below AP, you do worse than the average goes down. So when MP is above AP, it pulls up AP, it pulls up average, so average goes up. When the green line is above the white line will keep on rising. When the green line is below the white line, it pulls down white line. So that explains the first point and the second point. So when you do better than the average goes up. When you do worse than the average goes down. But what about third point? When MP meets AP at AP's maximum point. So this is the third point. Why is it that when MP is meeting AP, it's AP's maximum point? And the answer to this one is that before X, your AP was rising. After X, AP is falling. So at X, AP must be maximum. Usse pehle, before this it was going down, after that it was going, before that it was going up, after that it was going down. This means this is the point where it must be maximum. So this is the drawing for our short run curves, which shows us about how TP and MP is related, and then how MP and AP is related. Make sense, guys?